All right, so today we're looking at function modeling. We're mainly looking at three different ones: uh, linear, quadratic, exponential. So what's funny is that this part used to be on a test where it was just linear, quadratic, exponential, and I'd have people write absolute value, square root, and it was stuff that we'd never even covered. Okay, now some of the things that you're gonna notice that's a little different in this. That's not what I wanted. This is okay. This equation right here, it's still a quadratic. It's just in what's called vertex form. Okay. I actually like vertex form better. It's easier to graph. It's quicker, and things of that nature. Um, our exponential looks a little different. Okay. And, you know, we'll go through how to find all these and, you know, look at them for graphs and things like that. I will tell you for the quadratic, finding the A is usually the hardest, what people think is the hardest thing, but I try to find an easier way to do so. And then there's this thing that says to identify linear versus quadratic. Look at the first and second differences. I'll explain what that means because some of y'all are like, what does that mean? And then identify exponentials. It's usually really easy to look for the y values being multiplied. Okay, so if you look for the y values being multiplied, that's usually what you're going to end up getting in there. Okay, yeah, lots of information, vertex, HK, all that kind of stuff. And part of your standards is one, you have to identify them, and then two, you have to write the equation. So what I've tried to do in the past is do that together because you have to know what it is to be able to write the correct form. I don't, me personally, I don't want to take a day, especially since we're face to face, to do a day where we're just spinning. What is it? Exponential, and then that's it. And then the next day we do something else. Next day. Okay, so but this is what we're looking at here. All right. Are we good here? Does anybody need more time? Yes, no, maybe. All right. So it says identify them as linear, quadratic, exponential, and then write the equation. Okay. So that being said, number one, what type of graph is that? Yeah, linear. Thank you. It makes a straight line. It's linear. Okay. So that looks like a V. All right, linear, and we're going to have y equals something x. Okay. So this is our B right here, our y-intercept. So we're going to have +5. And then our slope looks like we went over 1, down 2. So this has a -2. Okay. Pretty simplistic. All right. Yeah. Yeah. Linear of all three of them is the easiest one to write the equation from a graph. Quadratic, I think, is the next easiest. Exponential gets a little tricky sometimes, but we'll be okay with that. All right. Number two, what type is this? Exponential. Yeah, so you could write expo. That's fine. We're not saying that it's an exponential marker. It's just exponential. We're just shorthanding it. All right. If it makes a straight line, it's linear. If it makes a ramp, it's exponential. If it's a U, either up or down, it's quadratic. Okay. All right. So for this, we got to find our A sub 0 and our R. Our A sub 0 is actually going to be easy. All right. Because that's our initial value. That's also like our y-intercept. Okay. So for our y-intercept, dang it. There we go. All right. It's right here at 1. All right. So we're going to have y equals 1 parenthesis. Okay. And all right. So let's think about this. Right here, this y value is 2. And the next y value is 4. And the next y value is 8. What are we multiplying to get from 2 to 4? What times 2 is 4? 2. Okay. What times 4 is 8? 2. So that's our growth value right there. So that's what goes right here. Okay. Now, the reason why we had the R of N and all that kind of stuff, that's because that will really play into effect Thursday when we look at arithmetic and geometric series and sequences. Okay. Huh? Can you add and multiply? Then you can do what we're doing Thursday. Okay. All right. So this would be a quadratic. All right. And the things we need to know is our A, our H, and our K. Now, here's the big issue with the quadratic. Okay. The original equation for a quadratic looks like this. Okay. It says a minus H. I don't know why it does that. Remember, they used like heroin like Tylenol, so they were probably high. Okay. But when we plug in stuff, it's going to actually look the opposite of what we plug in. Okay. Now, the easiest thing to find is our H and our K because this is our vertex. Okay. Our vertex is -2, 4. So this is our H, that's our K. So our H is -2, our K is 4. All right. Now, to find the A value, all right, remember these ratios are 1A, 3A, 5A. So think about it. How did I go from this y point right here of 4 to this next y value of 3? How do I go from 4 to 3? Yes, thank you. You subtract 1. So that's our A value. Okay, so when we write this, it's y equals negative. You can put a 1 right there if you want to. Now, because this is a minus h, if I plug in a -2, it actually becomes +2, because minus a negative, is plus a positive, and then +4. Okay, so that's where it gets a little dicey with that. Is on the h, yes. Okay, good question, because you answered it as soon as you asked it. But that is actually the h thing. That's what everybody has the biggest issue with. Okay, because remember, it was y equals minus h squared plus k. And if I plug in, that would have been, y equals negative x minus -2 squared plus 4. Well, minus a -2 is plus +2. Okay, so that's why that changed to a +2. Excuse me. All right, now we're looking at charts. All right, so we need to look at the y values. Okay, what is being done? How are my y values changing each time? Yeah, I'm adding 5. That is actually my m, or my slope. Okay, and when it's adding, this is linear. Okay, so I know I'm going to have y equals 5x. Okay. Now, our B is our y-intercept. That means that it's the y value when x is 0. So what is this y value right here? 1. So our equation is y equals 5x plus 1. Okay. Not too awful bad. Yeah, linears are easy ones. Okay. All right, now let's look at our y values right here. What do we notice about our y values right here on number 2? Say it again. Yeah, the y values. Yeah, it doesn't look like there's a like add or subtract pattern. Yeah, but what do we notice about these two and these two? They're the same. It's symmetric. What graph do we know all the y values are symmetric? Quadratic. Awesome. So this is a quad. Okay. Now, this is why it's so easy to write these, is because in the middle, this is my h value, this is my k value. Okay. So I could plug that in, y, x, because it's going to be minus -1, the same thing as plus 1 squared, and then minus 1. Now, to find our a value, okay, let's look right here. It's -1. How do I go from -1 to 0? Add 1, yeah. So our a value is 1, so you could write a 1 right there, or you don't have to. It's understood that if there's not a 1 right there, it's understood to be 1, okay? Kind of the same thing that we had when we were graphing them in standard form in the last unit. If it was like x squared or whatever, it was understood to have a 1 in front of the x squared term. Okay. All right. So let's look at this. What the heck is happening down here with these y values? They are multiplying by 3. When they multiply by 3, this means that this is an exponential. Okay. And this 3 is our R, or our growth value. So that's what goes in the parentheses raised to the x power. Okay. Now, to find our a sub 0 or whatever, that's our y-intercept. So what's our y value when x is 0? 3. The hardest thing about this is remembering each 3 of the forms, each 3 of the equations. Okay. That's why I think y'all are at an unfair advantage to years in the past, because this test next Tuesday is open notes and things like that. So, all right. Let's look right here. What's being done each time to our y values? You say it. You had it. Yeah, multiply by 2. Awesome. All right. So if it's multiplied, this one's an exponential. That's what goes in the parentheses. Okay, so we can just put 2 in parentheses, raise it to the x power. All right, what is our y-intercept? What's our y value when x is 0? 9. I heard it somewhere, and I heard it somewhere to the left, which is awesome because I have my headphone on and this is the ear that's deaf. So I actually heard it. I might not be as deaf as I thought. Thank you for clapping. That is a big issue with me, by the way. But I'll talk about that when I'm not recording. I'll tell you why my ear's dead. Okay. We don't need all of YouTube land to know why I'm deaf in my left ear. All right. So now, as far as recording goes, I'm going to kind of stop right here. And I'm going to let y'all do this your turn. This is not your homework. This is not your homework, believe it or not, FYI, BT dubs. This is something different. I'm just going to give y'all time to do this. But, you know, I may record it later. Who knows? Okay, roll time.